We're going to go through the OSI model and the TCP/IP model here. You need to memorize both of these, and I'm going to draw the encapsulation model right next to them so that you can be aware of what's what. In my professional experience, the OSI model was the model that was always used as a reference for if anybody needed to say something about, hey, are we working at the network layer? Are we working at layer 3? They would be referring to the OSI model. So the TCP/IP model is something that's there. They both describe the exact same thing, which is data communication. But the OSI model is the one that, in practice, most people would say, if we're going to go off in numbers, they're saying layer 3, layer 4, things of that nature. Layer 2 is just a layer 2 issue. A layer 1 issue means you have no electricity. So that's kind of funny. But usually the OSI model is the one that you would work on. The TCP/IP model is included as well to really just mess you up on the questions so that you have to memorize both. So keep that in mind. In both cases, you are getting all of the steps that are necessary to get from point A to point B in a data communications model. Let's start at the OSI model layer 7. Layer 7 is known as the application layer. And the application layer, that is not necessarily an application, but the ability for an application to communicate with the core network solution posted within the operating system, right? So do we have the ability to generate information that doesn't end up on the local screen, but the ability to generate information that we can send to another device someplace else? Without that, we can't go any further. So from the application standpoint, can we send networkable data to another processor to have it run someplace else? OSI model layer 6, the presentation layer. At the presentation layer, your system has to be able to discern against those two different types of data. Is this information that's going to go to my local processor and turn into something that's different on my local monitor? Or is this something that we're going to package differently, that we're going to set up so that we can send it someplace else? I always like to use the analogy of pizza at this point. There's a couple different ways to present pizza. It's still the same pizza. It's still the same exact food, but you would present it in a different way if you're eating it in a dining room versus the way that you would eat it if you were going to eat it in, say, a dorm room, right? So if you order pizza in the restaurant, they will deliver it to you on usually a metal tray or whatever, and the pieces are right there, and you get maybe a spatula, and you can open them up, and you just start eating. If you get delivery pizza, then the pizza gets put into a cardboard box for its transport to your home or to wherever it is you're at. So presentation is going to, even though it's the same thing, might be the same information you would process locally as you're going to process remotely. The build of the data may be different. That happens at the presentation layer. The third layer, or the fifth layer of the OSI model, is known as the session layer. Session layer just identifies if you've got someone or another device that you can communicate with on the other side. Is it even worth going forward? We want to communicate with this other device, host X. Is host X open to communication? Because if host X is turned off, we're not going to go really any further for this. Or, hey, do we even have a network card plugged in so that we can send this stuff to network X or host X? That's going to be checked at the session layer. So if you put those three together, they all really are part of the application layer of the TCP/IP model. And we'll write the encapsulation model in just in a second. If we were to write in the encapsulation model here, this part right here would be the formation of the data section. So this would be considered data solution for that. So now down below the top three layers, and that's really, if you're having problems in the top three layers, that's usually a problem based on the way that the information, that the actual data that you want to send is coded. And that would be a CIS type problem. That would be there's a problem with the way it was written, and that's why it's not processing correctly on the remote processor. Now, down below that, we get into the transport layer, the network layer, the data link, and the physical. When we get to the transport layer, this is where we're going to add a section that we had talked about before. We're going to add something called the segment header here. And the segment header says this. All right, we know that we're sending this someplace else. And we need to obtain a value, a port value for our machine, so that if there's a response to what we're going to send, that port is related to the application of the process that built this data, and will be able to hold a communication session with another device. So the segment header, segment layer, that's where the port values are going to be added in, and that is known as the transport layer. So it's the transport layer. Uh-oh, I changed slides. Uh-oh, hope it's the other way. There it is. Now, down at layer 3 is the network layer. The network layer is associated directly with the internet layer of the TCP model, but it's also associated directly with the packet header inside the encapsulation model, and that is, remember, that's where our IP addresses are going to be located. And that's where we're going to add that global address value. And then below that, the data link layer and the physical layer, this is where we're going to add our frame header here in the encapsulation model. And this has MAC addresses associated with it. So keep that in mind, and then down below this just turns into bits. And it's sent off to wherever it needs to go. Dot, 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 dash, 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 dot, 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 dash, dash, dash. Right, so a little bit about the different models. The OSI model, TCP IP model, both models built to break up the processes that are necessary for data communication. And we can take the encapsulation model. I guess I could write that on top of here. Encap model. I got to tell you, when I'm in the classroom and I draw stuff, my handwriting is about 1,000 times better than it is on these utilities. But that being said, that's enough for OSI model slides, and we'll move into the next section, which will be media after this one.